Hello dear students, in the last module we saw the basics of qualitative variables model. In particular, we saw the use of qualitative variables as independent variables. We also discussed the specification, feature and interpretation of ANOVA model. In today's module, I am going to illustrate the different uses of ANOVA model. ANOVA models help to assess differences between or among different groups. Today, I am going to argue how ANOVA models are better alternatives to the existing tools in statistics that are used to assess the differences among two or more groups, namely t-test and f-test. At the end of this module, we hope you would use the ANOVA models for that purpose. Let me illustrate a simple ANOVA model that may help you to understand the meaning of the coefficients in an ANOVA model. Let us take one model. This is a salary model for the employees. yi is equal to alpha plus beta DMI plus ui, where yi is the annual salary of ith employee, ui is the random error. Alpha and beta are parameters of the model, DMI is the dummy variable for male dummy variable for the employees. So, DFI is the dummy for ith employee to be female. Here DMI is equal to 1 if ith employee is male or 0 otherwise. DFI is equal to 1 if ith employee is female and 0 otherwise. In this one, we can specify two models based on their requirement to avoid the dummy variable trap. The first model is one dummy, actually in the gender there are two dummies possible, we are including only one dummy with an intercept. So, in this model alpha and beta can be interpreted. Alpha is nothing but the conditional average of y given DMI is equal to 0. That means, average salary of the base category or the female employee here in this case. So, alpha is nothing but average salary of the base category or the average salary of the female employee. Beta is equal to the average, the conditional average of y given DMI is equal to 1 minus the conditional average of y I given DMI is equal to 0. That means, average salary of the reference category, here in this case male, over and above the average salary of the base category or benchmark category, in this case female employees. So, this beta is nothing but the difference between the average salary of the male employees and the average salary of the female employees. Model 2, again this model will also avoid the problem of dummy variable trap. Here we have included the two dummies in the gender variable, gender dummy variable DMI and DFI, but we have dropped the intercept term. So, let us know by this yi is equal to beta 0 DMI plus beta 1 DFI plus ui. This beta 0 is nothing but the conditional average of y given DMI is equal to 1, that is the average salary of male employees. Beta 1 is nothing but the conditional average of yi given DFI is equal to 1, otherwise the average salary of female employees. So, this is how the model is specified and the coefficients are interpreted. From the data, we know the average salary of the female employee is rupees 26,032 rupees. The average salary of the male employee is rupees 41,442. The difference here is rupees 15,410. Let us discuss about the result of model 1, that is model with one dummy variable and the intercept included. So, here in this case yi hat is equal to 26,031.921 plus 15,409.862 DMI, and the t values of the respective coefficients are given below in the square bracket. F value 1,472 equal to 119.798, r square is equal to 0.201. In this model, the intercept we have already seen is the average salary of the base category, in this case female employees. So, this 26,032, actually this can be rounded off, is the average salary of the female employees that we saw in the descriptive statistics we discussed earlier. This we can say this DMI's coefficient is 15,410, this rounded off is the difference between the average salary of the reference category and the base category. So, this is the difference, So, we can from the estimates we can see these values, and we know we can have another model also. We can include the female dummy instead of male dummy, and that regression can also be run. In this case, the base category is the male. So, this one, the 41,442 is the salary of the base category in this case, because this is the included category, this is the reference category, female is the reference category, the left out is male. So, this indicates, the intercept term indicates the salary of the male employees, and this one shows the difference between the salary of the reference category and the salary of the base category. So, in this case this is negative because the average salary of the male employees are higher than the average salary of the female employee, and so now we are getting the negative. So, this is how the models we are getting the coefficients. Now, let us discuss the result of the model 2. In this case, the two dummies are introduced, but the intercept is dropped. In this case, we can very well say the coefficient of the male dummy is nothing but the average salary of the male employee. Here in this case, the coefficient of DFI is nothing but the average salary of the female employees. So, when the two dummies are introduced without the intercept, the coefficients represent the conditional averages of y given DMI and DFI respectively. So, from this we can see the results demonstrated, and the results we can very well see, right, how these values we got, and how the descriptive statistics are showing up. Now, let us summarize. So, which one is the best method? Result the model 1 or model 2? Usually the model 1 has got more applications than model 2. Of course, there are some places where the model 2 is applied, but still the model 1 has got more applications than the model 2. Let us take another example of the ANOVA model. Consider a categorical variable for education with 3 categories. The category 1 is illiterate, category 2 is school completed, category 3 graduate. So, theoretically we can generate 3 dummy variables for each category D0, D1 and D2. Here in this case we are going to include only the 2 dummies corresponding to the school completed employees and graduate employees. So, this is the model, wage model with these 2 categories D1I and D2I. So, this is the model where YI is the annual salary of ith employee, D1I is equal to 1 if ith employee completed school education, but not completed college education, 0 otherwise. D2I is equal to 1 if the ith employee completed college education and 0 otherwise. If this is the case, the conditional mean of yi given d1i is equal to 0 and d2i is equal to 0 is equal to beta 0, otherwise average salary of the illiterate employees, because beta 0 is the conditional average of the base category employees. Here in this case base category is illiterate employees, because for which the dummy variable is not included in this model. Now, the conditional average of yi given d1i equal to 1 and d2i equal to 0 is nothing but beta 0 plus beta 1, that is the average salary of the school completed employees. Beta 1 is, here in this case beta 1 is the differential average of the school completed employees over and above the illiterate employees. This is the base category, this is the reference category. So, this is the beta 1 is the differential average, the difference over and above the illiterate employees. The conditional average of yi given d1i is equal to 0 and d2i is equal to 1 is equal to beta 0 plus beta 2. This is nothing but average salary of the graduate employees, where beta 2 is the differential average of the graduate employees over and above the illiterate employees. In this model, T statistics of beta 1 and beta 2 would help assess the significance of beta 1 and beta 2 individually. In other words, the significance of difference between the school completed and the illiterate employees in average salary, the graduate and illiterate employees in average salary could be found. So, the significant difference between these employees in their average salary could be found. If the average salary of the illiterate, the school completed and college completed employees are mu 0, mu 1 and mu 2 respectively, we may conclude the following. Significance of beta 1 and beta 2. Beta 1 is the differential average of the school completed over and above the illiterates, and this is the differential average of the graduates over and above the illiterate employees. Confirm that mu 0 equal to mu 1 and mu 2, because beta 1 and beta 2, if it is insignificant, that means no 0. So, there is no difference between the 3 categories of employees. insignificance of beta 1 and significance of beta 2 would confirm mu 0 is equal to mu 1, but not equal to mu 2. Similarly, significance of beta 1 and insignificance of beta 2 would confirm beta 0 not equal to mu 1 equal to mu 2. Significance of beta 1 and beta 2 would confirm none of them is equal, mu 0 not equal to mu 2 is mu 1 not equal to mu 2. So, these are all the three different cases we can differentiate, actually four different cases we can differentiate with the help of significant tests of beta 1 and beta 2 using t-tests. So, therefore, ANOVA model tests mu 0 equal to mu 1 equal to mu 2 against the three alternatives: mu 0 equal to mu 1 not equal to mu 2, mu 0 not equal to mu 1 but equal to mu 2, mu 0 not equal to mu 1 not equal to mu 2. And so, this is this type of distinguishing between four different alternatives is definitely better than F test, because F test only tests mu 0 equal to mu 1 equal to mu 2 against not equal. Not equal will include these three categories, but it can only say whether this is equal or not. So, F test only tests whether this is equal or not. So, in such cases ANOVA model is better, because from this we can differentiate between all the three categories separately. So, we can conclude that this simple ANOVA model gives a better result than the simple F test that we are using theoretically. Let us take another example. In the following salary model, the employee among of a company depends, the salary of the employee depends on gender. So, this salary model is taken here. One dummy is used, one dummy for gender is used. Y I is equal to alpha plus beta di plus ui, where y I is the annual salary of ith employee, di is the male dummy for ith employee. Alpha and beta parameters of the model, ui is the random error. Di is equal to 1 if ith employee is male and 0 otherwise. Let us take this case. Alpha is the average salary of the female employee that we already know. Beta is the differential income of male employees over and above the female employee. Now, the significance of beta will indicate whether the average salary of the male and female employees, the difference is significant or not. If the beta is significant, we will say the salary difference between the male and female employee is significant, and so the salary of male and female employee is different. But if beta is insignificant, we will say the differential the average income of male employee is equal to the average income of female employee. So, this is the usual t test, but in this case we can go a little further in testing, in using t test in this ANOVA model. If you include one more variable, a very relevant variable, that will really help enhance the potential of the t test, because this is the very usual case. The salary difference may be due to the educational difference among the employee. Otherwise, if you remove the educational differences of the employees, the differences in salary can be taken as the discrimination of the female employee. So, in such studies, the additional effect can be removed using the introduction of additional independent variables. So, now the introduction here in this example, introduction of education variable will give the model like this. After the introduction of education, this Wall-Lowell theorem says this will remove the effect of education on the salary. In that case, the beta will measure the difference in the salary between male and female employees after removing the effect of income. So, that may be a better measure for the discrimination in labor market. So, the t test simply helps to find the difference between the male and female employees average salary, but this one helps you to remove the effect of other relevant variable from the market, and so may help you to measure the real difference after accounting for the factors that may lead to the salary, which may help you to measure the discrimination in the labor market. So, this kind of t test is far more sophisticated than the simple t tests. So, ANOVA models in fact provide us a better framework than the simple t test that are coming theoretically in statistics books. So, ANOVA models are better than t tests. Let us summarize what we have learnt in this module. In today's module, I explained how the coefficients of ANOVA models are interpreted in practice. Also, we saw how ANOVA models are used as a better alternative to T and F tests. In the next module, we may discuss some more applications of ANOVA model. I hope you have enjoyed the session today. Thank you so much for watching.